Hello friends, today we are going to discuss steady running mixture requirements of SI engine. Steady running means the continuous operation of the engine at a given speed and power output with normal engine temperatures. Under the steady running condition, the mixture requirement for maximum power and for minimum specific fuel consumptions are different. First, mixture requirement for maximum power. You can see in this figure the effect of fuel air ratio on the indicated mean effective pressure at full throttle and part throttle conditions. The maximum indicated mean effective pressure occurs at fuel air ratio of about 0.08 for gasoline, which is little more than the chemically correct amount of the fuel. At full throttle and with the maximum indicated mean effective pressure mixture, the flame speed is high and the burning time losses are very small, since the piston is near the TDC and moves very little during the burning process. The effect of closing the throttle reduces the indicated mean effective pressure and the indicated power by reducing both the intake manifold pressure and the volumetric efficiency. The entire indicated mean effective pressure curve therefore lowers itself at part throttle as shown in figure. However, the intake manifold pressure also reduces the flame speed, which increases the burning time losses and which further reduces the indicated mean effective pressure as shown in figure. You can see the figure. However, the burning time losses at fuel air ratio of 0.08 are almost negligible for any given throttle position. The indicated mean effective pressure will be maximum at fuel air ratio of about 0.08 as earlier said, which is little more than the chemically correct mixture, that is stoichiometric air fuel ratio. Second is mixture requirements for minimum specific fuel consumption. You can see the second graph which shows the mixture requirement for minimum specific fuel consumption. The maximum indicated thermal efficiency occurs at a fuel air ratio of about 0.06 for gasoline, which is slightly leaner than the chemically correct fuel air ratio, because for the combustion excess air can be provided for this particular leaner ratio. A lean mixture lowers the maximum temperature, which favors the chemical equilibrium and specific heat of gases. If the mixture is made too lean, the flame speed reduces, which increases the burning time losses and lowers the efficiency. The indicated specific fuel consumption, that is ISFC, reduces as the indicated thermal efficiency increases. The important effect of throttling on ISFC is the change in time losses. The time losses are slightly affected at fuel air ratio 0.08, but as the mixture is made richer or leaner, the effect of throttling on time losses becomes much larger. It is observed that from the figure that ISFC curve, you can see that ISFC curve for part throttle operating condition are very close to the full throttle curve at the fuel air ratio of 0.08, and it deviates at leaner and richer mixtures. The point of minimum ISFC at progressively richer fuel air ratio as the throttle reduced. Third is mixture requirement for various outputs. Figure shows typical curve for BMEP, that is brake mean effective pressure, and corresponding BSFC, that is brake specific fuel consumption, versus fuel air ratio for an engine operating and at different throttle positions. From the figure, it is observed that there is only one fuel air ratio and the throttle position which will result in the maximum power. This corresponds to point A at full throttle position will result in maximum power, which is 0.08. If it is required to reduce power by 80% of maximum, it can be done by reducing the throttle with fuel air ratio of 0.08 corresponding to point B. This will result in an increase in BSFC from point A to point B on the BSFC curve. You can see in the figure. The increase is due to reduced throttle causing less IMEP, keeping the friction mean effective pressure, that is FMEP, almost the same, thus reducing the mechanical efficiency. A more economical method is to maintain full throttle and reduce the fuel air ratio to point C. You can observe the figure and point C. This gives lower brake specific fuel consumption because the lean mixture improves the indicated thermal efficiency. If still less power is desired, reducing the fuel air ratio further at full throttle to point E would be undesirable, as the burning time losses would increase and misfiring may result. It would be better to reduce the throttle to point D in such a way that it gives minimum BSFC.